today we are doing 7.3. What we're going to talk about is exponents raised to exponents. This is going to be rule number 4. So, very quickly, I'm going to remind you about our other rules, right? If we have x to the 0, that equals 1. Very good. If I have x to the negative n, we said that moves it to the bottom, and your exponent becomes positive. If we had x to the n times by x to the m, we kept the same base, and we added our exponents, right? Okay, our new rule is if I have x to the n raised to the m, we're going to multiply our exponents, which is x to the nm. So what I mean by that is, for example, if I have b squared raised to the third, what that really means is that I have b squared times b squared times b squared. And the way we would have done it yesterday is the base is b, and we would have added our exponents because they're all multiplied together. So 2 plus 2 plus 2 is 6. But we'd like a shortcut, right? So the shortcut means I can just multiply these exponents, and I get 6.
So in this parentheses, you multiply that.
Yep, exactly. Okay? All right. So let's do a couple examples, and then we're going to start to get a little harder. A little harder. We're going to start off easy, though. Example number 1. Yeah, it's just going to ask you to simplify. So as you're looking through here, the first few kind of start with 10 through 20-ish. We'll say 20-ish. Let's start with a really easy one. Let's say I have h to the third raised to the 7th. That's going to give me h to the what? 21. Just multiply those exponents together. Let's say I have w to the 2nd raised to the 4th. W to the 8th. Very good. Let's say I have a to the 1/2 raised to the 6th. 3, a to the 3rd. So just because it's a fraction, do the rules change? No, we're still going to multiply them. All right. So now let's take this a little bit further. Are you ready? All right. What if we had b to the 4th raised to the -3? We would get b to the what? -12, right? Because it's a negative. And then, am I done? Yes. It's got to go down to the bottom or the dungeon or however you want to call it, to the basement. It goes b to the +12. Okay? Questions so far? All right. One more on this example. One last one on this example. No, gosh, no. All right, let's say I have d to the 3rd times by d to the 5th raised to the 2nd. So here we've got to start with our last rule first. So we've got to do the exponent raised to an exponent first. So this d to the 3rd I'm just going to write down. And I'm going to times it by this d to the 5th raised to the 2nd. It'll be 10th. And then it goes back to yesterday. You add your exponents. Very good. D to the 13th. Questions? How we doing? That was pretty easy? Well, let me add a little more. All right, so here's example number 2. Example number 2 is going to kind of cover, let's go 22 through 32. These get a lot harder. So we're going to slowly work our way into them. All right, so the first thing I want to talk about, in all of my ones in the first example, I had no coefficients yet, did I? So we probably need to add that, huh? I think so. So let's say I have 3a to the 4th raised to the 2nd. When you have that exponent on the outside, we have to actually distribute it to everything on the inside. So this exponent belongs to the 3, and it belongs to the a to the 4th. All right, so really, no, I'll try again. So this would be 3 squared a to the 8th, right, because I have to multiply my exponents. And then a squared is what, Gage?
Whenever the exponent goes to the constant, can we just
Write it down as 9? Yeah, that's fine with that. I'm just making sure that when you look back at your notes, in your notes you know where that number came from, right? I don't want to jump or skip any steps, but yes, that's fine for you to do. All right, so let's try another one. How about if I have 4, a to the 3rd, b to the 7th, squared. So we've got to give this 2 to everything inside our parentheses because it's a whole entire group. So that would be 4 to the 2nd, a to the 3rd raised to the 2nd. We multiply. We would get a to the what? Good. And then b to the 7th raised to the 2nd, 14. So then the only thing I have left to simplify is that 4 squared, 16. A to the 6th, b to the 14th. Okay, not bad so far? Solve? There's nothing to solve. Let's keep going. All right. So here, I'm going to do example number 3. This is still part of the same section, though. This is still part of the 22 through 32. Let's say, again, I'm going to ask you to simplify, but I am stepping it up a little bit more, Jace. Are you ready? Okay. Let's say I have 2x to the 3rd. Whoops. Sorry, I got a little sloppy. My bad. 2x to the 3rd times by 3x to the 4th raised to the 3rd. All right. So first of all, we've got to start with this part, right? So this 2x to the 3rd, I'm going to bring down, and I'm just going to be timesing by what else I have, right? So this 3 on the exponent has to go to everything inside the parenthesis. So that would be 3 to the 3rd, x to the what? 12. Very good. 4 to the 3rd is 12, right? 4 times 3. Now I'm timesing 2 things just like we did yesterday, which means we multiply our coefficients together. So I have 2 times 3 to the 3rd, or 2 times 27, which is 54. Okay. Yes, 54. And then I have the bases that are the same, which is x. What do I do with those exponents? Add them. Very good. So we get 15th. Awesome.
I like this a lot better when we're doing
I know. I told you guys you would. Okay, hold on. I got a lot of talking. I'm sorry, Elena. What did you say? 54 was multiplying 2 times 3 to the 3rd. So your coefficients on both terms, right? Yes. It is 1024. Yeah, you got to go. 26. Sorry, 26. You got to go. All right, how about this example? Let's make it just a little bit tougher. How about if I had x to the 3rd, y to the 2nd, raised to the 5th, times by x to the 4th, y to the negative 3 raised to the second. Whew, that looks like fun. Let's start with the first parenthesis. We've got to give this exponent of 5 to everything on the inside, right? So, we're doing our x first. X to the third raised to the fifth becomes x to the 15th. Good. Then we got to go here. Y squared raised to the fifth. Y to the 10th. Times by. All right, let's go over here. I'm going to take this 2 to our x to the 4th. So we get x to the, good. And then we're going to take it to the y to the negative third, or y to the negative 6th. All right. Now we're timesing two things together, which means we start with our base. If I have a base of x, what do I do with my exponents? Add them. So 15 plus 8. Good. 23. My next base is y. What do I do with those exponents? 10 and negative 6. Awesome. Questions so far? Right, so you just got to remember, Jordan, to take it step by step. You'll notice that I don't try and do it all at once, right? Take it step by step. It'll keep it from being confusing. It'll help. All right. How about this one? Let's do 3b to the negative 2 raised to the second times by a to the second, b to the fourth, all raised to the third. Same section. All right, so we're going to start with the first parenthesis in this 2. That 2 has to go to everything on the inside, right? So I have 3 to the second, b to the negative 2 raised to the second, or b to the negative 4. Good. Times by, over here. I have a to the second raised to the third. Good. A to the 6th. And then we have b to the what? Awesome. All right, now we got to simplify. Let's start with our coefficient. We have 9. Now, before you get to the b, what letter should we do first? A, right? How many a's do we have up there? Good, that's it. And then we do our b. We have b to the negative 4, and we have b to the 12th, so we have b to the 8th. Is there anything else to simplify? No, that's it, right? Good. Okay. So here's my, what example am I on? 4 or 5? 4. Example 4. It's okay. It's all right. Example 4 is 34 through the 40. Last section. All right. Simplify and write as scientific notation. All right. So let's say I have 4 times 10. Times 10 to the 7th, all squared. So on this one, we still have to take this 2 has to go to the 4, and it has to go to the 10 to the 7th. So we got 4 squared times 10, and again, an exponent raised to an exponent. We multiply them, the 14th. All right. 4 squared is how much? Okay. 16 times 10 to the 14th. Tell me, Corbin, is 16 between 1 and 10? 15, yes. See, you guys are still thinking science class. But it's okay. So let me explain the difference between what I'm saying and what you hear in science class, okay? In science class, you already have the number and you're putting it into scientific notation, right? Okay, so you need to know how many you're moving and what that exponent is going to be. Here, you already have it in scientific notation, but you have to simplify it, right? So if we had the big number written down, that's different than what we're doing. So here, because we have to move this decimal over 1, the number is too big, right? So we have 1.6, we have to add 1 to our exponent, which is 15. So what you're doing in science, something like this, you would have had 1, 6, and then 10, or actually 14 zeros, right? And it keeps going and going. So then your decimal is way over here. So when you try and find where your decimal goes, you are moving it to the left, so your exponent is positive, right? But that's not how we are looking at it because it's already in scientific notation. Does that clarify it better? Yeah? Because I just don't want you guys to get confused between how you're doing it in science and how we're saying it in here. All right. Let's do one more really quickly, and then I'm done. Okay? All right. So here's our last one. Let's go with, how about 2.5 times 10 to the negative 4 raised to the 7th? 7th it is. All right. So we have 2.5 to the 7th times 10. What do we do with our exponent? Negative 28. All right. So now we got to simplify this first term. 610. Okay. 610 times 10 to the negative 28. All right. Is 610 between 1 and 10? Okay. So the decimal starts here. We move it over 1. We move it over 2. So we get 6.1 times 10. And since it was too big and we moved it twice, what are we doing to the exponent? Adding 2. Negative 26. Yes, I agree. Okay? Any questions? All right. Your homework is in the book, page 436, 10 to 40 even. I also have a posting in Google Classroom, of course. Okay?